questions? All right then. Today we're starting to work with what's known as a system of equations. And so what the particular kind of system we're going to work with is called a 2 by 2. It's called 2 by 2 because we're going to have two variables, x and y, and two equations at a time. Now, bless you. I think, was that a sneeze? No? Okay. Means finding a solution that works in both of the equations that we're given simultaneously. Here's a really simple little system. X plus y equals 7 and x minus y equals 1. That's an example of a 2 by system. We want pairs of numbers that add up to 7, but at the same time, the x minus the y has to equal 1. Well, can we guess and check our way to a solution? Yeah, eventually. If we think about what's going to solve x plus y equals 7, we just need pairs that add up to 7, like 1 and 6, or 2 and 5, negative 3 and 10. All these add up to 7, right? And the next one, it's a little harder to notice right away maybe, but if the first number minus the second number is 1, doesn't that mean that the x has to be just 1 more than the y? So we get things like 2 and 1, because 2 take away 1 is 1, 10 and 9, because 10 take away 9 is 1, and 15, 14, we could have 102 and 101, that's ridiculous, but it would work. And when we get all the way over here, 4 take away 3 is 1, 4 plus 3 is 7, that means this is our solution to the system of these two equations. This is the solution that works in both of them. Each one by itself has millions and millions of solutions, but we want the one that works in both, and there's only one. Okay? Here's a little more sophisticated system. Y equals 1/3 x plus 1, and y equals negative 2x plus 8. So if we started making a list here, this would take some time because we'd have to pick x values that we can divide by 3 and all that. You know, I don't want to do it that way. But now, if we graph y equals 1/3 x plus 1, there's the y-intercept 1, and the slope of up 1 over 3, up 1 over 3. On the same piece of graph grid, also draw y equals negative 2x plus 8. So there's 8 for the y-intercept, and the negative 2 is telling us go down 2 over 1, down 2 over 1. And remember, I know you listen to every word I say and you write it down and all that, and you're making videos and playing them for your friends, and they're on TikTok and on and on and on. But remember what I said a minute ago. Everything on here is a solution to that. Everything on here is a solution to that. So what's so daggone special about that point? It's going to work in both equations at the same time. And what is this point? What is this wonderful point? It's 3 for x and 2 for y. If we try that out, 3 for x and 2 for y, that would be 2 equals 1/3 times 3 plus 1. A third of 3 is 1. We're in college and we're still saying 1 plus 1 equals 2, so it works in that. And does it also work in the second equation, 3 for x, 2 for y? If I put in a 2 for y and the 3 for x, this makes a negative 6, and 2 does equal negative 6 plus 8. Okay? So the big idea today is when we get these systems of equations, we're going to draw the graphs, and the solution for the system will be the point where they intersect, the point that they share in common. All right. So here's we've talked about these already, but supposing we didn't, here's how we would begin. If I'm solving this system, well, these are both in standard form. So if I plug in 0 for x and solve for y, I get 7. 7 for y. And if I plug in 0 for y and solve for x, I get x equals 7. Well, now I've got those 2 points. And I'm glad I brought my ruler today, because this is why I've been nagging you all about using graph paper, because now it really matters, because if the graphs aren't accurate, you won't get the right point of intersection. Oh, there's good time to skip pen. Brand new pen. Okay, so there's, just give me 1 second. There's x plus y equals 7. Yes.
So why the x was 7 there again?
I'm sorry?
Why the x was 7?
Because when I plug in 0 for y, all that's left is it says x equals 7. Just in this top equation.
Yes.
You see it now? If I plug in 0 for x, it says y equals 7. If I plug in 0 for y, it says x equals 7. Okay? Now I'm going to do the same thing with the other equation. I'm going to plug in 0 for x, and that does not affect the minus sign. Maybe I ought to write this one out. If I put in 0 for x, this is what remains. Negative y equals 1. So if we would reverse the sign on both sides by multiplying by negative 1, we get y equals negative 1. The y-intercept there is negative 1. And if I plug in 0 for y in this bottom equation, it's going to say x minus 0 equals 1. And so that disappears, and we get the x-intercept is 1. In terms of physically drawing the job of drawing the graph, just using those 2 points, do you see how if I don't hold my ruler just perfectly, something might go wrong? So here's where I have to do this smart thing of thinking, looking at those 2 points, I can see that the slope is up 1 over 1. So I use that, I'll go up 1 over 1 instead of using the ruler. Up 1 over 1 a few times, and oh, there's the solution right there. I just went through the solution. So what is the solution? It's 4 for x and 3 for y, as we said when we did the guessing and checking a little while ago. Of course, the solution is the same. But you do notice that the graph is giving us the same answer we got from making these lists. But doing it this way is way more efficient. Okay, questions? All right, and I'm not going to bother with this one, because this one is the same graph. It's already drawn. I keep meaning to change this, and I forget, but it's just a rerun of that. If we drew these 2 graphs, we'd see that, and the solution would be 3 for x, 2 for y. So let's do a new one. Here's a nice new one. And both of these are in standard form. So for this top equation, if I plug in 0 for x and solve for y, this part disappears. It says minus y equals 3, and if I multiply both sides by negative 1, I get the y-intercept is negative 3. Same equation, I'm going to plug in 0 for y now, and it's going to say 3x minus 0 equals 3, and of course the 0 is gone, and x is 3 divided by 3 is 1. So when we use 0 for y, we get 1 for x. And I could use the ruler through those 2, or I could just use the idea of the slope. What's the slope here? Up 3 over 1. Up 3 over 1. Graph paper makes this a lot easier. Or down 3 into the left 1. Now I'll get my... We're going, there we go. Not too bad. And for the other equation, if I plug in 0 for x, and solve for y, plug in 0 for x and solve for y, it's just going to say y equals 2. So the y-intercept is 2. And when I plug in 0 for y, it's going to say 2x plus 0 equals 2. And so the x-intercept here is 2 divided by 2. It's 1. So it's that same point. And going from there to there, I go down 2 over 1, down 2 over 1. If I do that a few more times, the line shapes up very nicely. But I already see what the solution is, right? The solution is that common x-intercept that they had. So to finish the job, we're not quite finished yet. What we need to do is say, here's the solution. The solution is 1 for x, 0 for y. Any concerns there?
Where'd you use 0?
Where'd I get 0? I plugged in 0 for y and solved for x. When I plugged in 0 in this bottom equation, when I plugged in 0 for y and solved for x, it would then just say 2x equals 2, meaning that x would be 2 divided by 2, which equals 1.
So then,
And the same thing happened with the top equation. When I plugged in 0 for y, I had 3x equals 3, and I divided by 3, and I got 1, 0. Okay? This one's slightly more convenient because one of them's in slope-intercept form. I'll start the graph of this at -5 on the y-axis, right there. Positive 2 slope. I go up 2 over 1, up 2 over 1, as many times as I want, or down 2 and to the left 1. I'll try to make a nice sharp line through those points, if I can do that. Okay, pretty good. Bless you. How about the other equation? If I plug in 0 for x, it's going to say 3y equals 6. If it says 3y equals 6, then y is 6 divided by 3. If I plug in 0 for x, I get 2 for y. And I also want to get the x-intercept. So to get the x-intercept, again, working with this equation, I'm going to plug in 0 for y. And then it's going to say x equals 3 times 0 equals 6. And this part is gone because it's 0. I'm left with x equals 6. I have 6 for x when I use 0 for y. So where's that? That's right there. Everything okay up to there? All right. Can you see what the slope is? So go from one point to the other, like if I go from here to here, I go down 1 over 3, and it's happening again, going to the next point, down 1 over 3. If I want more of my picture up in this quadrant, I'll go up 1 and to the left 3. Do that a few times, and there's the second graph. So what's this all about? This is all about finding this, the point that they share in common, the x and y that they share in common. So the solution is, what is it? It's 3 for x and 1 for y. Do you see where I'm getting that information? That point has an x value 3, 0, 1, 2, 3. And it has a y value 1. Questions? Yes.
How did you get the other, like these points on the other?
How did I
On the
get
left
this
side.
one?
No, I know how you get this one, the other one. On the left side,
This?
yeah.
This one?
No, the up one,
This one?
yeah.
When I plugged in 0 for x. When I plug in 0 for x, then it says 3y equals 6. So y equals 6 divided by 3. Oh yeah, I wrote it here. See, when I plug in 0 for x, it would say 0 plus 3y equals 0 plus 3y equals 6.
No, why did you went up one over 3?
How I get this point?
Yeah.
Because, all right, see, I had those 3 points, right? I mean, I had this point from the y-intercept work and this point from the x-intercept work. And then I had this point that coincided with the other graph, and I can see what's happening. Remember, it's always the same pattern, whether you look at it going this way or going this way. Every time I go sideways 3, whether it's left or right, the change in y has to be 1. So if I'm starting here and I go over 3 and then go down 1, I'm not going to have a line anymore. I'm going to start making a triangle. We don't want that. But if I go to the left 3, just like going to the left 3 there, to continue the pattern, I go up the same 1, over 3, up 1. Did that sort it out? Okay. I'll do this at the bottom because I think you're going to see some of these questions too. Is 5, 7 a solution to this system? How could we tell without drawing the graph? I don't want to draw the graph. Bless you. Why don't I want to draw the graph? You shouldn't want to draw the graph either. Look at the y-intercept, it's 22. And this thing, you're going to get a x-intercept of 13 over 4, and this is going to be a pain in the neck. So if all you're asked to do is yes or no, is such and such a solution to the system, you plug it in, and it's not good enough if it only works in one equation, it's got to work in both. So if we try this out, just to be really explicit, if I plug in 7 for y and 5 for x, there's a question mark. Is that true? Yes, because that's negative 15, and 7 does equal negative 15 plus 22. Am I done with this question? No, because it has to work in both equations. It might work in one and not the other, right? So if I plug in 5 for x, minus the y value, minus 7, does that actually give us 13? So that's 20 minus 7, that is true. Okay, so the answer is yes, and the answer is yes to that also. Solving this by graphing, you'd need a really big piece of graph paper, and it'd be kind of a pain in the neck. So we're not going to solve all these systems by graphing. We're going to get another method tomorrow and another method on Wednesday. But you will be asked to do at least one by graphing on midterm 3. Okay, let's look at these. These are kind of special cases. These are examples of dependent, inconsistent, and independent. Let's see what that means. If we graph y equals negative 3/7 x plus 3, we start at that y-intercept of 3. And before I even do anything, do you know what to do? Do you know what you're going to do at home later? With that slope, negative 3/7, I'd be going downhill in the ratio of I go down 3 and over 7, which puts me right there. Or, starting at the y-intercept, I can go up 3 and to the left 7, which would put me right there. Okay? Well, let me get my cheapskate ruler out and connect those. Very nice. Good job, Mr. Dane. So that's That's been taken care of. What happens with the other equation when I substitute 0 for x? If I substitute 0 for x, what do we get for y? If I substitute 0 for x, that disappears. Y is 21 divided by 7. I get the y-intercept 3. Ooh. So, yeah, I'm looking, I don't have a red pen. It's right on top of that point, isn't it? I'm gonna put it right there. When I plug in 0 for y, that part disappears. 3x is 21. That means x is 21 divided by 3 is 7. And that is this point right here. So what's going on here is the graph of one equation is smack dab on top of the graph of the other. And that means that this is what we call a dependent system. This is called the dependent system. Anything that's a solution to the first equation is also a solution to the second equation. And in fact, you might say, it's the same equation twice, just written differently. You know, if I take this bottom equation and solve it for y, look what happens. Let me do that. I have 3x plus 7y equals 21. If I take away 3x from both sides, I have 7y equals minus 3x plus 21. And then if I divide by 7, I got y equals negative 3/7 x plus 21 divided by 7 is 3. And you see it's coming out the same as the first equation. Okay, and such things do actually pop up in real applications. So here we would say there are infinitely many solutions. Okay, and that doesn't mean you can use any two numbers you want. The x and y still have to obey the equation. So what this means is there's infinitely many solutions because either one of them by itself has infinitely many solutions, but in this case it's whatever works in one is also going to work in the other, because it's like one of them's the other in a Halloween costume. It's the same equation twice. Any question about that before we go to the next special case? Okay. Top equation says y equals negative 3/7 x plus 5. So the y-intercept is 5. And the slope is negative 3/7. I have that same slope again. Down 3 over 7 puts us right there. Or up 3 and to the left 7 puts us right there. And if I connect those, there's that line. And does the bottom equation look familiar? Yes, that same equation from the first example. So the x-intercept is still 7, and the y-intercept is still 3. And if I connect those points, are we going to get any point on both lines at the same time? No. Why not? What's that word? It's not a bad word. What's that word? They're parallel. Yeah, so they're never gonna have a common solution. And that's what we call an inconsistent system. All right? And then the third one is the one we usually get to work with, is what's known as an independent system. If I graph this last system, y-intercept is 3, slope is negative 3/7. So up 3, left 7. We got this again, right? Let me use the ruler. Let me not set a bad example. Okay. How do we graph the bottom equation? The y-intercept is -2, and the slope is +2/7, so I go up 2 and over 7, and I land right there. I could also go down 2 and to the left 7, and that would put me right there. What's the important thing about all this? We do have a solution to the system of equations. We have a point that's on both graphs at the same time. What's the solution to the system? It's 7 for x, 0 for y. It works, that pair, that xy pair will work in both equations at the same time. Any concerns?
And so how is the last one a special case?
That's a good, yes, it's not really a special, it's just kind of, it's here to contrast with the other, and to learn these vocabulary words. Yeah, it's not really a special case, good point. These two are special because, infinitely many solutions, no solution at all. This is the more typical occurrence.
So, this one is, you said,
The one in the middle is no here, I should have said this, or I should have wrote this. No solutions. Infinitely many solutions, and here we could say these words, exactly one solution. Okay, and this method of doing graphs later on in life, you'll do things like this. Remember graphing these? Graph a parabola, and at the same time, graph a straight line. So if that's a system of equations, of two equations, this has two solutions, right? But that's not till 1148. We don't even do that in 1075. Well, let's try some of these now. I got 3x plus y equals 1. If I plug in 0 for x, I get y equals 1. If I plug in 0 for y, I get x equals 1/3. So I'm not going to try to work with a x-intercept that's a fraction. I'm going to do a little bit of work. I'm going to solve this for y. It's not going to take very long. I got 3x plus y equals 1. Okay, one step, take away 3x from both sides. It's going to say y equals minus 3x plus 1. Now that it's in slope-intercept form, and notice it agrees with what I got a minute ago, I start at 1 on the y-axis, -3 for the slope, go down 3 over 1, down 3 over 1, or up 3 and to the left 1, and a nice straight line through all those. Okay, what's happening with the other one? The other one I don't need to change to slope-intercept form, but you know what? It's so easy to do. Let me just add 2x to both sides of that, and then it'll say y equals 2x plus 6. Might as well, right? Second equation, add 2x to both sides, and now it's in slope-intercept form. I can start at the y-intercept of 6 right there, and the slope is positive 2. Starting at that y-intercept of 6, I go up 2 over 1. Or I can go down 2 and to the left 1, and there's the solution right there. Down 2 to the left 1 a few more times. And if I'm only interested in the solution, and I'm in a hurry, I can already see what that is, but like if I'm doing this on the midterm and I've got to show the graph, or in the homework and I'm supposed to show the graph, I want to have the whole picture. What is the solution here? I'll write answer, that takes less writing. It's -1 for x, and what's the y value? 1, 2, 3, 4. -1, 4. All right, And if you plug these in for x and y, they should work in both equations. Any questions about that example? Okay, Mr. Dane, shut up for 2 minutes. Let us try one. Okay, try this next one. Try this one, the y equals 1/2 x plus 2, etc. While I mark down who's absent today. Deal. With Lizzie Sasser. Right. Testament. Okay. Shall I wait? Okay. So I drew y equals 1/2 x plus 2, y-intercept 2, slope positive 1/2, and then I thought I'd better talk about this one while I do it. If I plug in 0 for x, it's going to say 0 minus y equals 1. So if minus y equals 1, y equals minus 1. Then when I plug in 0 for y, it's going to say x minus 0 equals 1, or just x equals 1. So the problem, if you want to call it a problem that I have here, is I want to make an accurate line so I hit the other one at the exact correct place, yeah? And I don't want to depend on, am I holding this just the right way? Like we saw a little while ago, observe the slope and use it. The slope is really, really simple. It's up 1 over 1, up 1 over 1. Do this a few times. See, because if I had the ruler just a little bit shaky, I might have hit this point right here, and that's not really the answer. Here comes the answer right there. There's our solution, and what is it? It's 6 for x and 5 for y. Okay, if I finish the job and I've done this accurately, I get that point of intersection 6, 5. Any question about that one? It's starting to look semi-easy, I hope. Let's try another one. Okay, this is in standard form, but 5 and 2 both go into 10. That's nice. So if I plug in 0 for x, plug in 0 for x and solve for y, I get 5. So the y-intercept is 5, 4, right there. Plugging in, plugging in 0 for y and solving for x, I have 5x equals 10. So x is 10 divided by 5 is 2. What's the slope here? Down 5 over 2. Let me do that again. Down 5 over 2. It just makes it easier for me to make the line correctly. If I got a more stable placement for my ruler. With the points being further apart, yeah? Excuse me. And the other equation is in the friendly little slope-intercept form. Y-intercept is -4, and the slope is -1/4. So I don't go over 1, up 1 and over 4 like that. I go down 1 and over 4, and I'm at the solution immediately. Let me do it one more time. Down 1 over 4, and let me make a point over here and point up there. Okay. Finish the job. And the last thing I want to do is write down the answer. What's the answer? What's the answer, Mr. Dane? It's right there. What is that? 1, 2, 3, positive 4 for x, and 1, 2, 3, 4, 5, negative 5 for y. Anything left to say about that before we turn the paper? Okay. These are nice. Oh, look, they're both in slope-intercept form. They should go pretty quickly. The y-intercept is 5, right there, and the slope is positive 1/2. You know how nice that is to know that stuff and not have to make a table? So these would take so much longer if we had to do that. And the other equation, the y-intercept is at positive 1. Slope is negative 1/2, so I go down 1 over 2 a few times. I go up 1 and to the left 2 a few times. I just went crashing through the solution right here. Okay, so what's that solution? The answer is 1, 2, 3, 4. It's negative 4 for x. Negative 4 for x, and 1, 2, 3, positive 3 for y. Is that all right? Okay, this one's a little bit of a pain in the neck because if I plug in 0 for y, I get a whole number. But when I plug in 0 for x, I get a whole number for y. But when I plug in 0 for y, I get a fraction for x. So I got to change this to slope-intercept form. I'll start by adding 3x to both sides, and then it will say 4y equals 3x plus 4. And now I'm going to divide everything by 4. That'll make it say y equals 3/4 x plus 1. So I changed this to slope-intercept form. The other one's already in slope-intercept form. Now it's not too much work. Y-intercept of 1, slope of positive 3/4, up 3 over 4, up 3 over 4. Same line going down 3 and to the left 4, down 3 and to the left 4, like building a staircase. And do that. Okay. So there's that graph. And the other one, y-intercept is negative 8, 2, 4, 6, 8, right there. Slope is positive 3. Go up 3 over 1, up 3 over 1, up 3 over 1. Oh, bingo, there's our solution. There's that graph. And here's our solution. Solution, the answer. 1, 2, 3, 4 for x, positive 4 for x, and 1, 2, 3, 4, positive 4 for y. Look all right? Okay. And then this one, y-intercept is negative 2, slope is negative 2/3. Go down 2 over 3, down 2 over 3, up 2 to the left 3. And another slope-intercept form. Oh, y-intercept is negative 5. And the slope is positive 1/3, so I go up 1 over 3, up 1 over 3, or down 1 and to the left 3. Do we already see the solution here? In a minute, we're going to do we're going to have a quiz on Wednesday. We're going to do the practice quiz, so try to stay till the end, please. Positive 3 for x, 1, 2, 3, 4, negative 4 for y. 3, negative 4. That's the solution. Questions? Okay. One more. Oh, and this one we can do the easy way. Plug in 0 for x. Plug in 0 for x. And we'll have minus y equals minus 3. So y will equal 3. 0, 3. And plug in 0 for y. Plug in 0 for y, cover up the y. 3x equals negative 3. X will be negative 3 divided by positive 3 is negative 1. All right, points are kind of close together, but understanding how the slope works, I can get some more points. I'll just go over 1 and up 3, just like those first 2 points do. Or I'll go down 3 and to the left 1. And very quickly get a decent graph. Good enough for what we're doing here. And the other graph, it's in slope-intercept form. I start at negative 2 on the y-axis, and the slope is positive 1/2. I go up 1 over 2, up 1 over 2, up 1 over 2, or down 1 and to the left 2. What just happened right there? We hit the solution right there. Okay, well, don't forget that important last step. The answer is, what is it? Negative 2 for x and 1, 2, 3, negative 3 for y. Any question before we turn the paper and do the practice quiz?